So we're doing OCR's paper 5, the higher tier non-calculator paper from November 21. And if we have a look at the grade boundaries, paper 5, you need 17 marks for a 4, 29 for a 5, 41 marks will get you a grade 6, right up to 79 marks for a grade 9 on this paper. So question 1, we've got fractions to multiply, and we've got 3 and 4 sevenths multiplied by 7 tenths. Never ever work in mixed numbers when working with fractions. So 3 sevens are 21. Add the 4, that's 25 sevenths. Just convert it to an improper fraction, and we're multiplying by 7 tenths. You could multiply the tops, multiply the bottoms, but I've got a 7 on top and a 7 on bottom, so I can just cross cancel. And what we get is 25 tenths. It does say right as a mixed number, so I'm just going to count up in tens. 10, 20 would be 2 whole ones, and then there'd be 5 tenths left over. Be careful with this can cost you a mark. 5 tenths is the same as 1/2. So there's your final answer. Question 2, my mate Asmir is answered a question, and it says product of prime factors, answer in index form. Let's just check his answer. 2 times 2 is 4, times 2 again is 8, and 8 times 5 is 40. The only problem, he's not written his answer in index form. It should be 1, 2, 3 2's, so 2 cubed, multiplied by 5. And part B of this question, it says find the value of x. We've got 1/16 equals 2 to the power of x. Well, 2 times 2 is 4, times 2 again is 8, and times 2 again is 16. So I think we've got 2 to the power of 4. 2 to the power of 4 is 16, but I want 1/16. So to get the 1 over, I need a negative index. 2 to the power of 4 is 16. 2 to the negative 4 is 1 over 16. Question 3, we've got a mechanic that's got a tin containing 5 litres of engine oil. Straight away, I can see we've got millilitres coming up. So I'm going to take that 5 litres and multiply by 1,000 just to change that to millilitres. There's your conversion to change to millilitres. The rest of the question says each week we use 450 millilitres, and after 9 weeks we'll use over 80% of the oil. So this is what we've got. Every week we use 450, and we do that for 9 weeks. So let's do 9 lots of 450 to see actually how much we use. I'm just going to use a grid method to do that. So we've got 450 multiplied by 9. 9 noughts are 9 fives are 45. 9 fours are 36. Add on this 4 makes 40. So we use 4,050 millilitres in the 9 weeks, and that's out of the 5,000. So let's write that as a fraction. 4,050 out of 5,000. And what we need to do now is just see whether this is over 80% or not. So we need to turn this fraction into a percentage. Well, firstly, we can divide top and bottom by 10. So we've got 405 out of 500. If I can get this to out of 100, I'm golden, because that's my percentage. So to get 500 to 100, I'm dividing by 5. I need to divide that by 5. So how many 5s into 405? 5s into 4 is 0, remainder 4. 5s into 40 is 8. And 5s into 5 is 1. So this here is 81 out of 100. And that's 81%. Make sure you answer the question. The mechanic says after 9 weeks he's used more than 80%. Are they correct? You will get a mark just for saying yes. Question 4, we've just got a scatter graph. We've got data points in grey that have been plotted, and we've got to plot these remaining 4. So just make sure you're in the right place. January is down here. So I'm going to go across to 70 and up to 86. Across to 70 and up to 80. Just be careful. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's going up in ones. So 86 is there. Across to 44 and up to 60. Across to 44 and up to 60. Across to 37, that's there, and up to 48. 40, 2, 4, 6, 8. And across to 38, right there, and up to 50. Right there. It says in part B, describe the type of correlation. Well, these are moving upwards, and that would be positive. Part C on the next page says which student made the biggest amount of progress from January to February. And what we're looking for is someone with a low January score, but then a high February score. And I think the person that's jumping out is this person here. In January, they only got 30. And in February, they got 66. So that's the person with the biggest increase, low January score, high February score. And part D on the next page says work out the percentage change for this student. So percentage change, what we need is the actual change, the difference. Okay, and we just said we went from 30 to 66, so the change is 36. They increased by 36 marks. And to get percentage change, I'm going to do that change, 36, out of the original. And if I can change that to a percentage, I've got the percentage change. Well, this is quite a nice fraction because if we divide top and bottom by 3, then we get 12 out of 10. And if we multiply top and bottom by 10, we get 120 out of 100. The percentage change is 120%. Finally, part D, a very typical way to finish a scatter graph. We've got a student that scored 79 marks in January, and they're saying, can they use the scatter diagram to estimate what they got in February? If you look back at the scatter diagram, you will see that there is no January data beyond 66 marks, and this guy got 79 marks. So because the scatter diagram stops at 66, we're not allowed to use it beyond that point. Question 5, volume of a prism, and we've got this weird L shape, and what we're first looking to do is divide this front face into rectangles. We can't work out the area of this weird L shape. What we can do is work out the area of rectangles. So if we have a look at this as two separate rectangles like that, and we'll work on those. So let's find the missing measurements first. This whole bottom is 6. This top measurement is 1. So this top measurement here must be 5. 5 across there, and the 1 makes 6 in total. I'm going to do the same for the blue rectangle. This whole measurement is 3. This little bottom measurement is 1. So this here must be 2. And what we've got now is two rectangles that we can work out the area for. If we look at the blue rectangle, you actually need that. That is 3 high and 1 across. 1 across because that's 1, so that's 1. So the area is 3 times 1, which equals 3. If we look at the red rectangle, then that is 1 high and not 6 across, but 5 across. So the area is 1 times 5, which equals 5. They will be centimetres squared, but I'm just going to leave them as they are for now. The volume is going to be these two added together, because that's my total area. So I'm going to do 3 add 5, which is 8, and I'm going to multiply by this 4 to get volume. So 8 times 4 is 32, and that's centimetres cubed for volume. Question 6, just a case of knowing your types of graph. Direct proportion always goes through no, so it has to be this one, and it's always a straight line graph. So C is your direct proportion. And then inverse proportion, I'm afraid we just need to learn that one. Inverse proportion is this one, comes down in this curve shape. So that's D. Question 7, solving an inequality. Just do exactly the same as you would do if this was an equal sign. Okay, so if we've got brackets with an equation, we would expand these brackets. So I'm going to do 4 times x, which is 4x. 4 times negative 3 is negative 12. And that is less than x. Now, because I've got x's on both sides, I'm going to just leave them a second. Usually I'd get rid of the smaller x first, but that leaves 0 over here. I know not many people like that. So what I'll do is I'll add 12 to both sides. We get 4x is less than x plus 12. And at this point, I'm going to get rid of the smaller x's. So take x. And what you get is 3x is less than, that's gone away, 12. Final step, divide by 3. Divide by 3, and we get x is less than 4. It says show our answer on a number line. Well, clearly 4 is important, so I'm going to do a circle at 4, and I'm going to show that it's all of the numbers less than 4. Because there's no or equal to, I'm not going to colour this dot in. If that was or equal to, then I'd colour the dot in. But because it's not, I'm not. So question 8, we've got a table to complete and there's just one missing value, and the rule is y equals 6 over x. The x that we've got is minus 2. So we've got to do y equals 6 over minus 2, and 6 divided by minus 2 is minus 3. So that missing value is minus 3. We're then just going to plot these points. Okay, this here, you're just saying draw the graph from the table that you've got. Don't get confused by this. It's saying here are your values, draw the graph. So we're going to go across to minus 6 down to minus 1, across to minus 3 down to minus 2, across to minus 2 down to minus 3, and across to minus 1 down to minus 6. And then I'm going to change colour because we're then going across to 1 and up to 6, across to 2 and up to 3, across to 3 and up to 2, and finally across to 6 and up to 1. What we're drawing here is a 1 over x graph, or a 6 over x, and you'll see you've got this weird thing. If you try to connect all of these points, it's just not going to happen. These graphs go like this. Okay, so you've got this curve on this side, and then where the red crosses are, you've got a separate curve. These do not join up. So that's what you've got. It's called your reciprocal graph. Have a look at that. It's just a special type of graph you need to be aware of. Question 9, we've got a worker that gets a 10% increase and then another 10%, and he thinks that he's getting 20% altogether. This is a compound interest question dressed up. So if you've got no money to work with, always start with £100. On a percentages question, £100 is your best friend. If we find 10% of that, well, because we chose £100, that's nice, easy, £10. So to go up by that first 10%, we're going to do 100 add 10, which is £110. So that there is the first 10% increase. If we do another 10% increase, well, we're now starting with £110. So let's find 10% of that. It's not the same £10. 10% of 110 is £11. And if we go up by a second 10%, we do 110 add 11, which is 121. This here is showing that you have not gone up by 20%, because 20% of 100 is 20. So we should finish at 120, and instead we finish at 121. It does says what's the correct percentage increase. Well, because we chose £100 and we finished at 121, we've gone from 100 to 121, which is a 21% increase. Question 10, we've got some estimation to do, and we're looking to do pressure, and pressure is force divided by area. Now we're told the force. What we're not told is the area. All we've got is a rectangle, which is 4.9 by 4.1. So I'm going to draw that rectangle out and put those measurements in place, 4.9 and 4.1, and we need the area of this. And we might be panicking because this is a non-calculator paper, but remember, this is an estimate. So we're going to do not 4.9 times 4.1, 5 multiplied by 4. Just make that nice and easy for yourself. And 5 4s are 20, and that would be centimetres squared. For the force, we're not going to use 198. We're going to estimate and use 200. Again, use really nice numbers when estimating. All we need to do now is work out the pressure, which is force over area, which is 200 over 20. Take a 0 off. 20 divided by 2 is 10. And it would be newtons per centimetre squared. Question 11, we've got two triangles joined together, and I've done enough of these now to know if you've got two triangles joined together, 9 times out of 10, you need to work out the side connecting them. So even without reading through the question, I'm going to work on this blue triangle here, guessing that I'm going to find that side. This is 30, this is 10. That looks like a typical trigonometry question to me. So that is the opposite. This here, longest side, is the hypotenuse. And we're going to write down so, ka, toa. Straight away, opposite hypotenuse. This is a sine question. So let's write that out fully. Sine theta equals opposite over hypotenuse. And we can substitute. Theta is the angle 30. So we'll write sine 30 equals, the opposite is the thing I don't know, and the hypotenuse is 10. And then there's a one-step rearrangement to get question mark. I'm just going to times both sides by 10, and you get 10 times the sine of 30 equals question mark. Non-calculator paper, we need to know what sine 30 is. If you're unsure, just guess, and always go for a half. The sine 30 is a half. Half times 10 is 5. So this measurement up here is now 5 centimetres. I can start to actually look at the question. It says the ratio of the length BD, so the side I just found, to DC, that one, is 1 to 2.4. So this here is 2.4 times bigger than this 5. So I need to do 5 lots of 2.4. Well, if instead I do 5 times 24, remember non-calculator paper, 5 20s are 100, 5 4s are 20, that would be 120. So this is going to have to be 12, just coming down by a factor of 10. What we've got now is a new triangle to work on, and we're actually looking for BC. So I'm going to draw this triangle down here. We know this is 5, this is 12, and that's what we're looking for. This now looks like a Pythagoras question. A, B, and C. Pythag, A squared plus B squared equals C squared. A is 5, so 5 squared plus B is 12. 12 squared equals C squared. 5 squared is 25. 12 squared is 144. And that is C squared. 25 add 144 is 169. So C squared equals 169. C is the square root of that. Square root of 169 is 13. Question 12, looking at a box plot. And the first question says find the range. Well, range comes from biggest and smallest and the difference between those. So we just need to find those two values. It's a bit of a dodgy scale, this, but I'll just check what we're going up in. I think it's 0.02s. So let's just have a look. 7.62, 4, 6, 8, 10. That there would be 7.7. And then 0.246, 8, 10. Yeah, can you see where we're going up in 0.02s on this scale? It's a bit of a rough one. So this measurement here is 7.62, 7.64. This one is easy, it's just 7. So we're going to take away 7, and that comes to 0.64. Part B says how many mice have a length of at least 7.2 centimetres? Well, there's my 7.2, which is nice. And I want at least that length. So I want all of this part of my box plot. And remember, a box plot splits the data into quarters. So this here is a quarter of the data. And everything else is 3/4. So we just need to work out 3/4 of 60. 60 mice in total. 3/4 of 60 is going to be 15, 30, 45. Okay, 60 divided by 4 is 15. Times by 3 is 45. My pal Sam's got some mice. He picks out a mice and it's 7.35 centimetres long. And he says his mice are bigger than the ones in the pet shop, the ones demonstrated on the box plot. Why might he be right? Well, this here is the average. That's the median for the ones at the pet shop. So what we can say is Sam's mouse is bigger than the average from the pet shop. So he's quite right to say mine are bigger. Part 2 says why might he be not right? And what we can say is Sam's mouse could be an outlier. He picked one mouse, and that one mouse was bigger than the average. What if the rest are much smaller than the average? Question 13, just going to turn a fraction into a decimal, and a fraction is just a division, so 3/11 becomes 3 divided by 11, which is how many 11s in 3? The answer is 0, so we need some decimals and some digits to work with. 11s into 3 is 0 remainder 3. 11s into 30, well 11, 22 would be 2 remainder 8. 11s into 80, 7 11s are 77, and there'd be 3 left over. 11s into 30, same again, 2 remainder 8, and then we're going to get 7 remainder 3. Your answer is 0.27, where the 2 and the 7 are recurring. Part B, we're writing 0.48 recurring as a fraction in its simplest form. So what we're going to do is just follow this algebraic process. We're going to call x 0.48 recurring. Then we're going to work out 10x, which just moves the digits to the left, 4.8888. And we'll then do 100x, which again moves the digits to the left, 48.8888. And what I'm looking for is this repeating pattern after the decimal point, just 8s in this case. When you've found that, pick these two up, and let's do a subtraction. 100x take away 10x becomes 48.888 take away 4.888. And that repeating pattern means that all these 8s go away. 8 take 8 gone, 8 take 8 gone, 8 take 8 gone. You're left with 48 take 4, which is 44. I can actually work this out. 100x take 10x is 90x. And if 90x is 44, 1x, my original decimal, is 44 out of 90. It does say simplify the fraction, so let's half top and half bottom. And we've got 22 out of 45, and I don't think that's going to simplify any further. Question 14, and here we've got two ornaments that are mathematically similar. And it says the larger one is twice as tall as the smaller one. So straight away, we've got something called a length scale factor. And the length scale factor, we are multiplying by 2. Now this just goes on to talk about volume. The volume scale factor is not multiplying by 2. What we can do is work out some other scale factors. If this was an area question, then the area scale factor would be multiplying by 2 squared because it's an area. This is a volume question, and the volume scale factor is just multiplying by 2 cubed, and that there is the scale factor that I need to use in this question. My small ornament has a volume of 50, so what I need to do is take 50 and multiply it by the volume scale factor, which is 2 cubed. 2 cubed is 8, so I may as well just multiply by 8. 50 times 8, 5 8s are 40, whack a 0 on the end, you've got 400 centimetres cubed. Question 15, we've got some surds work to do. You can't add root 20 to root 45. We need to simplify both of these surds. So root 20, two numbers that multiply to make 20, 4 and 5. Why go for 4 and 5? Well, root 4 is 2. So what you're left with is 2 root 5, and that is root 20. Simplified. We'll do the same for root 45. Two numbers that multiply to make 45. I think that would be 9 and 5. Again, why go for 9 5s? Well, root 9 is 3. So you're left with 3 root 5s. And what we're doing is adding these together. 2 root 5s added to 3 root 5s is 5 root 5s. Question 16, we've got 60 students. And we own a smartphone, own a tablet, or own neither. This is absolutely screaming Venn diagram. If you've got one thing, another thing, and neither, to me, you're looking at a Venn diagram. So let's sort this out. We've got smartphone over here. We've got tablet over here. Always double check with your numbers. 40 and 27 and 8. So add those together. 40 add 27 is 67. Add 8 is 75. And that's too many students. There's only meant to be 60. So that's 15 too many. And they will often give you a case where you've got too many students in your Venn diagram. If there's 15 too many, 15 goes in the middle. They've been overcounted. Now we can fill in the rest of the Venn diagram. 40 on a smartphone. Well, there's 15. And here's all of the smartphone. This must be 25. 25 add 15 to get 40 altogether in the smartphone zone. It says 27 on a tablet. Here's tablet, all of this circle. There's 15 of them. There must be 12 here. 15 and 12 is 27. Don't forget those 8 people that own neither. They're going to be on the outside of the Venn diagram. Let's just double check that this comes to 60. 8 add 12 is 20. Add 15 is 35. 40, 50, 60. So that is now correct. It says a student is chosen at random from those that own a tablet. The minute you've been given that, you are only looking at these students that own a tablet. So I'm not looking at everyone, I'm just looking at these students. So it's out of 15 and 12 is 27. What's the probability that they also own a smartphone? Well, those 15 in the middle own a smartphone as well. So it's 15 out of 27. Question 17, we've got algebraic fraction to simplify. So I'm going to start with the bottom. We've got a quadratic, x squared plus 7x plus 10. Always look to factorise. And to factorise a quadratic, you've got x in a set of double brackets, and you're looking for two numbers that add to 7 and times to 10. What two numbers add to 7 and times to 10? It's 5 and 2. So I've factorised that bottom quadratic. I'm going to do the same for the top. We've got 2x squared minus 50. So straight away I can factorise this as in take out the 2 as a common factor. 2 times something is 2x squared. 2 times x squared is 2x squared. And 2 times something is minus 50. 2 times minus 25 is minus 50. I can actually factorise this again. This is a special case. You've got the difference of two squares. Square number, and difference. So that will actually factorise into double brackets. And what we need is an x in each bracket. Look at this 25. The square root of 25 is 5. So I'm going to put plus 5 and minus 5. If you're not sure what I did there, look up difference of two squares. There are not many questions they could give you involving that type of quadratic. I'm just going to rewrite my fraction. We've got two lots of x plus 5 multiplied by x minus 5 over x plus 5 times x plus 2. And you'll always find this when simplifying algebraic fractions. Same bracket top and bottom. So that cancels out and you're left with two lots of x minus 5 on top and x plus 2 on bottom. Question 18, typical circle theorem question. And before I even start answering the question, I'm going to look at this. I've got a tangent and a chord and an angle between the two of 70 degrees. Straight away, this angle here is 70 degrees. That's called alternate segment theorem. Tangent, chord, angle between them. That angle coming away from the chord matches this one down here. The minute I know this angle, I can actually work out this angle, because what I'm looking at now is a four-sided shape where all corners sit on the circle. This angle here will be 180, take away the angle across from it, take away 70. So that's 110 degrees. Opposite angles of a cyclic quadrilateral add to 180. So what I'm ready to do now is work on the triangle that the question is actually talking about. So let's have a look. We've got this blue triangle. We know that that angle there is 110. And it says the ratio of BCD, so this one here is BCD, to CBD, to this one, is 5 to 2. So this here is 5 parts, and this here is 2 parts. If I take that 110 and divide it by 5, I'll do that using a bus stop. 5 into 1 is 0, remainder 1. 5 into 11 is 2, remainder 1. And 5 into 10 is 2. So that here is 22. What I've done is taken this 110, divided it by the 5 parts that it's talking about in the question. Why would I do that? So now I can find this angle, which is 2 parts, or 2 lots of 22, which is 44 degrees. Question 19, we've got a coordinate, which is 5, 7 root 2. And it's talking about, this lies on a circle where the centre is 0, 0. What's the equation of the circle? Well, the minute we've got a coordinate, we've got an x value and we've got a y value. So I know an x and a y value. Circles always follow this equation. X squared plus y squared equals the radius, or r squared. Because I've got an x and a y, I can actually find the radius. So x is 5, so I'm going to do 5 squared plus y is 7 root 2. So I need to do 7 root 2 squared. And that is my radius squared. 5 squared is 25. 7 root 2 times 7 root 2. Well, 7 7s are 49. And root 2 times root 2 is 2. So I need to do 49 times 2. 49 times 2 is 98. and that is my radius squared. 98 add 25 is 113, and that is my radius squared. So what I can do is go back up to this part. That's the general format for an equation of a circle. I'm just going to say x squared plus y squared is my radius squared, which is 113. Question 20, we've got two equations, x squared minus 2y equals 5 and 4y plus z equals 7. It says write z in terms of x. So I'm going to start with this one, which says 4y plus z equals 7. And if I want z in terms of x, I need z equals. So that's what I'm looking for. So I'm going to take 4y from both sides and just get z equals 7 take 4y. So I've got an equation for z, but that is in terms of y, not in terms of x. So let's go back to this equation. If I can change this y to be in terms of x, then I can do some jiggery pokery. So watch what I'm going to do. I'm going to start with x squared minus 2y equals 5. I'm going to add 2y to both sides. Just bear with me as I work this through. And what you're left with is x squared equals 5 add 2y. Then I'm going to take 5 from both sides. And you get x squared take 5 equals 2y. And finally, I'm going to divide both sides by 2. And what we're going to get is y equals x squared minus 5 all divided by 2. What I did here is make y the subject. Over on this equation, I made z the subject. What I'm going to do now is replace this y with all of this expression. Because y is that, I can swap this y for it. So what we're left with is z equals 7 take away 4 lots of, not 4y, 4 lots of this. 4 lots of x squared minus 5 over 2. I'll make that bracket a single giant bracket. And that is complete, that is finished. We could make this, we do need to simplify this, and all we've got to simplify is this here. I'm timesing by 4, then dividing by 2. 4 divided by 2 is just 2. So what you end up with is z equals 7 minus 2 lots of x squared take 5. This 2 came from 4 divided by 2, which is 2. Question 21, we've got a sector. Someone's worked out the area for us, which is 40 pi. What we don't know is this angle theta. So if we've got the area, always best to work backwards first and find the angle. So the area of a sector is the missing angle theta out of 360. 360 because that's the degrees in a full circle. So theta out of 360 multiplied by pi multiplied by the radius squared. We know the area is 40 pi, so let's rewrite this. 40 pi is the area, equals theta over 360 times, well, 10 squared is 100, so you're going to get 100 pi. We can start to solve this to work out what the angle theta is. Just divide both sides by pi, that will get rid of that. Next step would be to times both sides by 360. That will get rid of this here, but I need to do 40 times 360. Well, let's do 36 times 4 over here. 4 6s are 24. 4 3s are 12, 13, 14. That comes out at 144. But don't forget there's 2 extra zeros on for this. So what we get is 144 0 0 equals theta times 100. I then need to divide both sides by 100, so I can just get rid of those 2 zeros and you end up with theta equals 144. Probably a nicer way to do that, but it worked out for us anyway. So we now know this angle here is 144. And what we're actually looking to do is work out the perimeter of the sector. So I want all the outside edge. So we'll start with arc length first. And arc length is theta out of 360, same as for area, but multiplied by pi, multiplied by diameter this time. It's a proportion of the full circumference. So what we end up with is 144 out of 360 times the diameter would be 20. So we're left with 20 pi. I can start to simplify this. I can divide both sides, top and bottom, by 10, and that will kill that down. I can do 2 times 144, which is 288. So what you end up with is 288 pi over 36. And I can actually simplify this fraction. So let's just make that as nice as we can. Half in top and bottom again, we're going to end up with 144 over 18 pi. Half top and bottom again, half of 144 is 72. So we ended up with 72 over 9 pi. These will both divide by 9. You end up with 8 pi. 72 divided by 9 is 8. So the arc length is 8 pi. The perimeter is going to be 8 pi, this arc length, plus 10, which is plus 20. Just double check. It says a plus b pi. If you want, I can say that's 20 plus 8 pi. Final question on this paper, we've got an algebraic proof to do, and it just involves loads of brackets. So if you're ever unsure what to do on an algebraic proof and you've got brackets, just start expanding. You've got 2n plus 1, and we're going to multiply by n minus 3. 2n times n is 2n squared. N times 1 is 1n. This would be minus 6n, and this would be minus 3. And all that is going to simplify to 2n squared plus 1n minus 6n is minus 5n minus 3. I'm now going to multiply that by this third bracket, which is n plus 2. And what we'll get is 2n cubed minus 5n squared minus 3n plus 4n squared minus 10n minus 6. I'm just going to simplify this separately. We get 2n cubed minus 5n squared plus 4n squared is minus 1n squared. Minus 3n minus 10n is minus 13n. And then we've got the minus 6. So that is my triple bracket expanded. I'm going to expand this here. And this was a much easier set of brackets to expand. 3n times n is 3n squared. And 3n times 7 is 21n. And we're adding these things together. So that is all my brackets expanded. All I need to do now is simplify this stuff. Well, I've got 2n cubed. I've got minus n squared plus 3n squared. That would be plus 2n squared. Minus 13n plus 21n is positive 8n. And then we've just got minus 6. I've got most of the marks just for expanding brackets and simplifying. It says prove that this is always even. Well, if something's even, it's going to be a multiple of 2. So I'm going to take out a factor of 2 from all of this. 2 times something is 2n cubed. 2 times something is 2n squared. 2 times something is 8n. And 2 times something is minus 6. That there is how you show an even number. Anything multiplied by 2 will be even.